Hello and welcome to my channel. In this video we are going to solve a competitive examination question from circles and circle theorems, and this is a multiple choice question. So we have 4 options over here. So let us start with this question now. In this diagram, points A, B, C, D are cyclic. QP and RP are tangents at points A and B respectively, and they meet at point P. Angle CAQ is given as 48 degree and angle ACB is given as 64 degrees. Find the value of angle BDC plus angle CBP plus angle ABP. So here we can see 4 options are given. So let us see how to solve this example now. Now here we can see that a circle is given and 2 tangents are touching it, that is tangent PAQ and tangent PBR, and the tangents are touching the circle at 2 points, that is A and B. Now here it is also mentioned that ABCD is cyclic. So we will see what are cyclic quadrilaterals later. So to begin with, let us try to find out the angle ABC, that is this angle. And to find out this angle, we are going to make use of a circle theorem, which is alternate segment theorem. It states that the angle that lies between the tangent and the chord is equal to the angle made by the same chord in the alternate segment. Now here we can see that a circle is drawn and we have a tangent AB and a chord BC. Now this chord BC divides this entire circle into 2 segments. One is the small segment called as the minor segment, and the other one is the larger segment called as the major segment. Now according to the alternate segment theorem, if an angle is made between the tangent and a chord in one of the segments, say for in this case it is going to be in minor segment and angle X is made, then the same angle will be made by the same chord but in the alternate segment. So this is the chord BC, which is making an angle in the major segment. So here angle D also becomes angle X. Now another example is, we can consider BD as a chord. So let us say that this chord is making an angle of Y degree with the tangent. That is in this segment, as we can see. That is the minor segment for the chord BD. So the same chord is making an angle at point C in the major segment. So if this chord is making an angle of Y with the tangent in the minor segment, then the same angle will be made by the same chord in the major segment at point C. So here we get angle Y. So let us see how we can use this theorem to solve the example above. Now here in this diagram, PAQ is the tangent and this is the chord AC, which is making an angle of 48 degree with the tangent. Now the same chord is making an angle at point B in the major segment, like this. So using the alternate segment theorem, if angle CAQ is 48 degree, then angle CBA also becomes 48 degrees. Now once we have got this angle, let us focus on the triangle ABC. Now in triangle ABC, we have the angle C, angle B. So let us try to find out angle A by using angle sum property of a triangle. So according to the angle sum property of a triangle, all the angles of a triangle should add up to give us 180 degree. So to find out angle A, we are going to subtract these 2 angles from 180. So this will give us 68 degrees. So this is the value of angle A in the triangle ABC. So let me write here 68. Now we found out the angle A. Now let us focus on the cyclic quadrilateral ABCD. And here, since we need to find out the angle BDC, that is this angle which is missing, we are going to make use of another circle theorem, which is cyclic quadrilateral theorem. It states that the opposite angles of a cyclic quadrilateral add up to 180 degree. Now cyclic quadrilateral is a quadrilateral whose all 4 vertices touch the circle. So here we can see that all the vertices of this quadrilateral ABCD are touching the circumference of the circle. So we call this as cyclic quadrilateral. Now according to this theorem, the opposite angles of this cyclic quadrilateral will add up to 180 degree. Now here in this diagram, angle A is opposite to angle C. So when we add up these 2 angles, we should get 180 degree. Similarly, when we add the angle B and angle D, which is opposite to the angle B, it should add up to give us 180 degree. So let us see how we can make use of this theorem above. Now here, since it is mentioned that ABCD is a cyclic quadrilateral, here angle A is opposite to angle D, So when we add these two angles, we should get 180 degree. So simply to get the angle D, we are going to subtract 68 from 180 degrees. So this is going to give us the value of angle BDC as 112 degrees. So we have written here 112. So now we have got this angle, that is angle BDC. Now let us try to find out the angle CBP. Now to find out the angle CBP, let us try to find the angle BAP first. So this is the angle we need to find. Now to find this angle, since we know that PAQ is a straight line, the angle of a straight line is going to be 180 degree. So to find out this angle, we are going to subtract 68 degree and 48 degree from 180 degree. So this is going to give us the value as 64 degrees. So here we get the value of angle PAB as 64 degrees. Now once we have found out the value of angle PAB, we can also find out the value of angle PBA, that is this angle. Now using the two tangent theorem, we know that when we draw two tangents to a circle from the same external point, then the lengths of the tangents are going to be same. That is, length PA will be equal to length PB. That is by using two tangent theorem. So if we look at PAB as a triangle, this is an isosceles triangle with sides PA equal to side PB, which means angle PAB will be equal to angle PBA. So angle PBA also becomes 64 degrees. Now it becomes easy for us to find out the angle CBP. That is the second angle. We have to simply add up 48 and 64 to get angle CBP. Next, to find out the angle APB, since we can see that PBA is forming a triangle, again by using the angle sum property of a triangle, we can find out the angle P by subtracting these two angles from 180 degree. So this is going to give us the value as 52 degrees. That is for angle APB. So let me just write here, this is angle 52 degrees. Now we have got all the angles which we need to find out the sum of these angles. That is, angle BDC is 112 plus angle CBP. Now CBP is the sum of these two angles, that is 48 plus 64. So let me write here 48 plus 64 plus angle APB, which we got as 52 degrees. So adding these, we get the value as 276 degrees. So let us see if this is in one of the options. So yes, we have option C, that is 276 degrees. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out this playlist where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.